Ladies and gents, my name is Brandon Stover. Welcome to the How to Solve Climate Change course from Plato University. Causes, systems, obstacles, solutions to this global challenge is what you're going to learn here today. When you're ready to learn more skills, join us for free at plato.university. Let's get started with today's lesson. We'll have our expert guests briefly introduce themselves and their credentials for why they are able to speak to this topic.
I'm Daniele Visioni. I'm a research associate at Cornell University. I'm a climate scientist. My background is in stratospheric dynamics and stratospheric chemistry and the feedbacks between the two. I've been working on the problem of ozone recovery and stratospheric aerosols and the impact of things like volcanic eruptions on climate for the last 10 years or so.
Can you explain succinctly what geoengineering is from a first principles perspective?
So people use the term geoengineering to mean a lot of different things, but using the definition that the IPCC, the Intergovernmental Panel on Climate Change, uses, geoengineering is any attempt to try to affect the energy balance of the planet. CO2 affects this balance already by trapping more long-wave radiation from escaping to space, which is how the planet regulates temperature. And geoengineering would try to aim to affect that balance in another way by preventing a small part of the incoming solar radiation from arriving to the surface, thereby trying to cancel out the forcing from the greenhouse gas.
Speaking to your research and the aspect that you focus on, why would that help to solve climate change?
Climate change is an incredibly huge and complicated problem. Overall, it's only reducing emissions and avoiding new emissions will prevent climate change from getting worse. But the CO2 that is in the air already is going to take centuries, if not more, before it gets removed. So people have proposed various methods of direct removal of carbon dioxide from the atmosphere. But those methods for now have not been proven to work at scale. And while we all hope that they might, it is unlikely that in the next few decades, they will actually make a dent into the climate change problem. And so from this perspective, what geoengineering could do is buy us some time and prevent some of the risks that we're already seeing. And that the IPCC says that these risks are also going to make it harder eventually to reduce our emissions or to scale up CDR, because it means that we're going to have to use our effort, our money to adapt to the climate change that is already happening. So if we could find a way to reduce those risks in the medium term, so in the next decade, that could potentially help. But eventually, geoengineering is not the solution to climate change.
And so could you steelman the other side and say why geoengineering may not be the solution or why it wouldn't work?
Sure, because it is affecting a system that is already complicated. And if we do it in a way, there is not just one way to do geoengineering. First of all, there are many proposed techniques. Some of them we can observe from analogs in the climate natural system that they might work, but how they are done and deployed eventually, that could actually make the problem worse rather than solving it. Because if there was just one country aiming to cool the planet however they wanted, or if we were doing it, before having enough information, because for now, the only kind of information that we have are through climate modeling, we could be introducing other risks. So especially if we go into the topic of geoengineering and deployment before we have enough information, it is most certain that we're going to actually damage the climate more than we would try to save it.
Yeah. If geoengineering different solutions are put into place, are there a group of people that would benefit more? And is there a group of people that may be harmed more?
That again depends a lot by who is doing it. And it depends on a lot of things. So in general, the risk right now is that there are just a few countries that are doing most of the research. And so eventually those could be the countries that benefit from it the most. Countries that have the capacity to do it technologically. So because they have aviation, because they have the knowledge to do it, like big nuclear power, kind of the US or China or India. And on the other hand, if the decision to do geoengineering at a global scale depended just on those countries, of course, the countries that already have not enough voice in the climate policy space, they could be the one more harmed. So especially considering that the countries that are already seeing most of the risk from climate change, our countries in the tropics are the most the poorest countries and the developing countries. And so, on the other hand, so as I said before, the main point of what geoengineering for now is studying it and making sure that these kind of studies do not happen only in the United States, but also so that there is a fundamentally grassroots, bottom-up expertise of climate scientists also in other countries and especially in developing countries, that when those issues will be discussed in international assessment, they can have a voice.
Did you explain the nuts and bolts of how geoengineering works?
The idea is to prevent some parts of the incoming solar radiation from reaching the surface. Not all the solar radiation that arrives at the top of the atmosphere actually reaches the surface already. There are plenty of things in between space and the surface that reflect a part of it. There's aerosols, so tiny particles, whether they're solid or liquid, those reflect solar radiation. Clouds, of course, reflect a large part of the solar radiation. And then on the land, the albedo of the planet, so the reflectivity of the surfaces of the planet, they also reflect part of the incoming solar radiation. So essentially, the idea is, can we enhance some of that reflection in some ways? And we've seen, as I said before, there are plenty of natural analogs that we can draw from. The main one for stratospheric aerosols is volcanic eruptions. We have observed during the 20th century that there have been at least 5 volcanic eruptions that were explosive enough that they launched a lot of sulfate in the form of SO2 into the stratosphere. So not in the part of the atmosphere that is very well mixed and where it rains, but in the part of the atmosphere where there are no clouds and the only removal processes are gravitational. And so we've seen after those volcanic eruptions that these sulfate aerosols would form and would stay for 1 year or more in the stratosphere. And they did indeed cool the planet. We observed it in temperature record. The same way, so the idea there is, could we do something like that and actually go in the stratosphere, put some SO2 every year, and make sure that these aerosols reflect a part of the solar radiation? That is not the only geoengineering methods that have been proposed. Another one that also comes from a sort of natural analog is marine cloud brightening. Basically, the idea is, we have observed also that when there are ship tracks on the ocean, sometimes the emissions from those ship tracks, they do brighten the clouds that are already present, those marine stratocumulus. And those are also very persistent clouds. And we can measure the radiative forcing effect that a brightening of those clouds would have. So the question there is, can we imagine some form of naval vessel that could spray sea salt from the surface of the ocean in the lower troposphere and brighten the clouds that are already present? And would that work? Finally, another method could be the observation that cirrus clouds, so ice clouds in the upper part of the troposphere, those are clouds that are almost invisible to solar radiation, but they're made of tiny ice crystals, and so they trap infrared radiation just like CO2 would. And so the question is, could we somehow affect those clouds, remove a few of them, and allow more planetary radiation, more infrared radiation to escape to space?
For geoengineering to work as a solution, what innovation or policy needs created?
Fundamentally, there are 3 issues. The first one is technological. With all of these, so the first one is technological. Could we actually do it? When it comes to stratospheric sulfate, the point is that right now there are no planes that can carry a load of anything all the way to the stratosphere, not in a continuous way. That is not a huge technological hurdle. It's just that there has never been any need to do that, but it is one. So for now, we couldn't do it. When it comes to marine cloud brightening, the issue is that we do not yet know what is the exact size of these sea salt particles that would be necessary to brighten the cloud. We can only guess for now. There's still a lot of need to understand in terms of aerosol cloud interaction. So we don't know if we would have technological capabilities to actually spray those clouds. And finally, for cirrus clouds, kind of the same problem as stratospheric aerosols. You would need to have these planes very high up in the upper troposphere, trap those clouds, and try to find a way to reduce them through some form of seeding. This is the technological hurdle. Then there's the political one, of course, which is, well, even if you could do something like this, who would decide? And this is really, if you imagine a complicated issue, usually the metaphor that is used is the one of the thermostat. Whose hand is on the thermostat? And considering the way the world works right now, it's very hard to imagine a governance system that could be global, that could make sure that everybody manages to agree on how much cooling to do. And this is very connected to the third issue, which is the scientific one, which is, would any of these things be safe? The CO2 forcing is a forcing that is applied from the bottom, warm from the bottom up. If you try to prevent solar radiation from reaching the surface, that is the forcing that you're applying, a cooling that you're applying from the top down. So these forcing will never cancel each other out perfectly. So there will always be a residual. And understanding what would this residual do, how would it affect the climate is really important. And we can only investigate it through using climate. And there are, of course, again, many other things. For instance, we know that stratospheric aerosols also affect stratospheric chemistry. Again, we've seen it with volcanic eruptions. So we need to better figure out how would the increased load of stratospheric aerosols affect ozone. Ozone in the stratosphere is really important because it shields us from UV. But if there's too much ozone, we actually, especially at mid-latitude, there is not enough UV of the good kind to produce vitamin D, which is very important for development, especially in adolescence. So any change to stratospheric ozone is something that needs to be evaluated. Once the aerosols come down from the stratosphere, they might actually add to the acid deposition in the soil. So eventually there's a whole range of interactions that we need to better figure out in order to have an assessment that can allow us to say, well, with some degree of confidence, well, this would be safe. And all of these are three problems, they kind of play out in the issue of, would we ever be able to do geoengineering? It's not just about the technical aspect, it's also about the safety aspect and also about the governance aspects. And those are very hard to separate, the three of them.
What are the best resources to learn more about geoengineering?
In the last few years, of course, there's plenty of scientific papers. The issue with scientific papers is that they're not aimed at a large public in any way. They are just a mean for the scientific community in a way to communicate with each other. At least that's how papers are thought of. But in the last year, there have been a few international efforts to produce some commentary around the state of geoengineering. There's a National Academy of Science, Engineering and Medicine, the US National Academy of Science, Engineering and Medicine. They put together an international group of scientists that they talked about the needs for research, what we know right now, and also what would be needed to have an effective governance. There's also a United Nations Environmental Program report that came out just last week or 2 weeks ago, where they also talked about basically the same thing. And then the Montreal protocols have every 4 years, they mandate an ozone report. So a report on the state of stratospheric ozone. And in the 2022 one, me and another few scientists from other countries have been tasked with writing a chapter, particularly talking about the potential threat of stratospheric aerosols from geoengineering to the ozone layer. So we had to write kind of a long assessment over what SAI is, what stratospheric aerosol geoengineering is, and what would it do. So those are a few more technical work. There's also an SRM, that's the other way geoengineering is called, SRM, solar radiation modification or management or standard reflection method. And so one of our PhD students wrote a primer intended for a more lay audience around the topic. And that's also a good version. There's also a few YouTube videos that I can think of that kind of discuss the issue from a more basic perspective.
Right now, you're speaking to passionate students who want to actually solve problems like these. What top 3 skills should they study so that they actually have the ability to do so?
The interesting thing in a way about climate change and about geoengineering is that it can be approached from literally any perspective. So, of course, the main thing is understanding the problem. So having a good understanding of the climate system and on the Earth system as a whole, it's really important. Understanding that it's not just an atmospheric physics problem, but it's also a problem that has to do with ecosystems, with how do we adapt to climate change and to geoengineering. So really a system view of the whole planet and the whole system that we live in is really important. And so if you want to try to address this problem from a scientific point of view, there's, again, plenty of subfields where you could be looking at: ecology, atmospheric science, atmospheric chemistry, meteorology, climate science, oceanography. For all of them, I have to say that probably the main skill is definitely being very adept at data analysis, because that's what most of science is right now. We have these incredibly huge, complicated models, these climate models. We know that for a lot of things they work well, but they still have to be used critically. But they are incredibly large and complex. And so making sense of their output, it is very hard, and it involves analyzing really terabytes and terabytes of data. So data analysis skills are really important. But and the third one I would say is really making sure that whatever problem you're looking at, you don't look at it only from a scientific point of view, but also from a social one. So there is no way you can talk about geoengineering without at least being aware of the governance problems around climate change and around international treaties. So the ability to connect science to the actual impacts and to the people that actually would feel these impacts is really important.
Any final recommendations for the audience?
I would say that whenever you hear this topic discussed in news, be really skeptical. Be both really skeptical of people claiming that this is a solution to climate change, that is the solution to climate change. Also be fairly skeptical of people claiming that we should not be talking about this at all because of some form of moral hazard. Because if we talk about this too much, then people would not be scared into reducing emissions. This is nothing to do with being scared, but just being aware. And more information is always good. So both be skeptical of people who seem too sure that this would work and that are claiming that we should be doing it already because there's still a lot of research that we need to do, but also be skeptical of people that do not want this issue to be talked about at all.
Excellent points about geoengineering were made in this lesson. Create a chart listing the potential pros and cons of various geoengineering techniques. Reflect on the ethical, social, and environmental implications.
Thank you for taking the How to Solve Climate Change course. If you want to learn the skills to solve this global challenge, join us for free at plato.university for exclusive content, extra resources, and actionable exercises with every lesson. This course was produced by Plato University, where students turn passions into purpose and learn skills to change the world. Learn more at plato.university.